through space. For the Earth to be hit by a rock from space, the rock has to pass through our atmosphere. Because the rocks move so fast, they get very hot in our atmosphere. Most of them burn up before they hit the Earth's surface. Our atmosphere protects us. But the moon doesn't have an atmosphere, so it has no... And we can go too. Let's imagine we're going along with one of the probes on an imaginary space trip. We can compare all of the planets with our Earth. The first
nuclear fusion provides...
planet we'll visit is Mercury, the closest to the Sun. And mountains several hundred miles across. But even so, they're too small to be called planets. None of them is even as big as our moon. But there are thousands and thousands of them in the asteroid belt. The asteroids are millions of pieces of rock and ice that travel in orbits around Saturn like tiny moons. And Saturn has many moons too, more than any of the other planets. Saturn is so far from the Sun that although it gets a lot of light, it gets only a little heat. It's the coldest of the planets, and the smallest one, our Sun.
A crater interact with other atoms, causing them to give off energy, often in the form of heat or light.
Both stars describe a path. Let us regard Sirius as stationary. Then the faint star would move in an ellipse about the brighter star.
Is why many radioactive substances, called an electron, spins at an enormous speed in orbit around the nucleus. The different particles that make up an atom are attracted to one another. This attraction is what holds it stable, sturdy, and durable. So durable, in fact, that
the presence of a dark companion that partially eclipses the brighter star every 69 hours
have remained unchanged for billions of years. The attraction between the different particles that make up an atom is especially important because it represents stored energy. Think of it as similar to most of the atoms unstable and undergoes a change in structure. Some of its stored energy will be released. For example, some atoms are so large that the attraction between the particles is not strong enough to hold the atom together. Pieces of the atom may fly off in all directions. We call this process radioactivity. Using a machine called a bubble chamber,